You cannot directly multiply radicals that have a different index. So up until now, I could say, oh, the square root of 2 times the square root of 3, since they're both square roots, is the square root of 2 times 3, or 6. I can bring them under the same radical. Why? Because the indices are the same. However, if I were to have a cube root and a fourth root, I can't bring them under the same radical this directly. Indirectly, I can if they have the same index. Well, how would you do that? Well, this is the cube root of x is x to the 1/3. The fourth root of x cubed is x to the 3/4. Properties of exponents say it is now, if the bases are the same, you add the exponent, so it's 1/3 plus 3/4. And here's the arithmetic. 1/3 plus 3/4, common denominator is 12. So 4 over 4 gives you a 4 over 12, and 3 over 3 gives you a 9 over 12. 4 plus 9 over 12 is 13 over 12. So that says this guy now is multiplied. He is the 12th root of x to the 13th. And can you simplify him? Yes. Because I've got more x's than my index, this becomes x times the 12th root of x. So the same thing would be true if I had the 5th root of 2 and the cube root of 7. Now the bases aren't the same, but I certainly can put them under the same radical. And, well, what do you mean by that? Well, the common denominator between 5 and 3 is 15. Take 2, and this is the cube root, or this is 2 to the 3/15th power. This is 3 to the 5/15th power. So what this is saying is this. This is the 15th root of 2 cubed times the 15th root of 3 to the 5th. Now do they have the same index? Yeah, you can bring them under a single radical, which is what they did here. This becomes the 15th root of 2 cubed is 8. 3 to the 5th is 243. Now you multiply them together and you can see they got the 15th root of 1944. I'm not quite sure why you'd ever want to do that, but just in case you do. But I can bring them together if they don't have the same index by making them the same index. So that's what's going to be true here. This is a square root, that's a 4th root. This is a to the 1/2 times a to the 3/4. So the bases are the same. This is a to the 1/2 plus 3/4. Common denominator is 4, so I'm going to multiply the first one by 2 over 2. This is a to the 2 over 4 plus 3 over 4. This is a to the 5 over 4. And now they'd be under the same radical. This is the 4th root of a to the 5th, which can be simplified. This is a 4th root of a.
I'm getting lost. How is it for a 4th root of a?
Okay, I need a group of 4. What is the largest number?
4. Oh, I see. Okay.
This is a to the 4th and a. So that's how you're going to get a 4th root of a. It's only because you only have 5 a's, so. This is the more difficult of the concepts. The good news in college algebra, we never use it, so. That may be the good news. Now on this guy, this is a 2x and it's raised to the 1 power. That's the radicand. So it's 2x to the 1/5. The whole 2x is in parentheses. Times, this is 2x to the 4/3. This is 2x to the 1/5 plus 4/3. And the common denominator is 15. So this is 2x to the 3/15 plus 20/15. Your book tends to just leave the answer in fractional exponent form, 23/15. Well, it says, okay, what did it tell me to do? What's the instructions? Write my answer in what? Radical form. Now, the examples that they give, did they write their answer in radical form? Let's go up and look at the example. Neither one of them they wrote it in radical form. I wrote it, oh yes, this guy right here. Write your answer in radical form. And see here they said write your answer in radical form. Did they write their answer in radical form? No. Brats. Okay. So what is this? This is the 15th root of 2x to the 23rd. Okay, which is the 15th root, well, 2x to the 23rd, 23rd, no, Peterson. It is not 23rd, what is it? 15. My white tape is failing me. 15 and then a 2x to the 8. That gives me 23 of them. Which gives me a 2x. And I have to put, I had to put it in parentheses. In this case, I probably don't need to. Times 2x to the 8th. And this is the 15th root. Don't forget your index. I almost did. Two x to the 8th. That still doesn't look like an x, but that's what it is.